In this video we're going to have a look at a proof involving the Theorem of Pythagoras, so that can be your heading, Theorem of Pythagoras. Now this is a fairly easy one once you see the answer again, and it's a short one. So we've been given a triangle ABC, and there's a line down the centre going from B to D, which is perpendicular to AC. So if you look here, we actually have two right angled triangles formed. Prove that AB squared minus AD squared equals BC squared minus DC squared. Now when you get these questions, first of all, look at what they're asking you to prove. And if you look at the AB and the AD, AB is this length, AD is this length, both of them are the right hand side of the triangle. They're both on the right. We'll just put or there for right. Whereas BC squared and DC squared, BC is from here to here, DC is from here to here, both of them are on the left hand side of the triangle. So obviously we're going to have to get some kind of expression for the right hand side and some kind of expression for the left hand side. Now because they're right angled triangles, the first thing we do is we look at our Theorem of Pythagoras and see can we get anything from that. And let's look at the right hand side first. Theorem of Pythagoras, what could we say? Well, we could say that AB, which is the hypotenuse squared, is equal to the other two sides squared. AD squared plus BD squared. Okay, that's one expression we can write. And we can write down a similar expression for the right hand, or sorry, that's the left hand side. Oh, I got my left and right mixed up. That's left, that's right, that's left, and this is right. So on the right hand side then we can do something similar. We can say, well, BC squared, which is the hypotenuse of the right hand triangle, is equal to DC squared plus BD squared. Now when we look at both of these triangles and when we look at both of these equations, they share one common element. They share this side here. They share BD. We have BD in this equation and we have BD in this equation. So now I'm going to rewrite both of these to give me BD on one side and everything else on the other side. BD squared would equal AB squared, and to get BD on its own I'd have to take away AD from both sides, AD squared. So what I'm doing there is I'm taking away AD squared from both sides. Here I'd have to take away DC squared from both sides, and I'm left with BD squared equals BC squared minus DC squared. And if you look at the expressions we've got, we know we're kind of going in the right direction because they're asking us to prove AB squared minus AD squared, which is what we have here, is equal to BC squared minus DC squared, which is what we have here. Now both of these expressions are equal to BD squared. So BD squared equals BD squared, so therefore AB squared minus AD squared equals BC squared minus DC squared. So QED, we've proved what we need to prove because BD squared is obviously the same as BD squared.